All right, boys and girls, welcome to day 2 of section 5.3, solving trig functions. So we're actually going to start off with example 7. And in this topic, we're going to cover squaring and converting to quadratic type. Okay. And so the first example that we have, they're asking us to find all solutions of 1 plus secant of x equals tangent of x. Okay. So a couple things you might notice. And this is how you know you're going to be scoring is secant and tangent don't have any direct correlation. Okay. Tangent is sine over cosine, and secant just doesn't have any direct correlation this way. But the moment I square both sides, then we're going to start to see some correlations, okay? So here we go. Whatever I do to one side, I do to the other side. So in this case, I'm going to be squaring both sides. So as a result, this will give me 1 plus, I'm going to expand it. So this is going to give me 1, oops, I said 1 and I wrote a plus, sorry. 1 plus secant of x and 1 plus secant of x equals tangent squared of x. So if you notice, all I've done technically on this side is just expanded. I didn't do anything. And on this side, I just distribute the square. Okay. But in doing so, the only thing that I could do here is FOIL. So we're going to do FOIL to this side. Okay. And in doing FOIL, I'm going to end up, let me move the camera just a little bit. Sorry. In doing FOIL, I'm going to, and again, you can do FOIL in your head. I could do this just a lot faster, okay? Sorry, I'm just not going to show the work for it because I can do it a little bit faster. So again, first, outer, inner, last. So 1 plus 2 secant of x plus secant squared of x. But previously we had learned that we don't want to really work with two different trig functions. So we want to try to change tangent squared of x to secant. And I could do that because I can apply one of the trig identities. Tangent squared of x is actually the same as secant squared of x minus 1. And again, that's using a trig identity, okay? So either you have it memorized or you're using your index card. That's up to you. Or the book, okay? But that's where I got it from, a trig identity. Okay, so now remember, whenever we solve an equation, we always want to set it equal to 0. So one of the things that I can do right now is add 1 to the right side, add 1 to the left-hand side. Okay, this one's going to cancel, and here we're going to have 2. So let me move this up a little bit. So we're going to have 2 as a result here, okay? Plus 2 secant of x. And then we're going to move this to the left-hand side, so secant squared x. So I'm going to subtract. And in doing so, this secant squared of x will cancel, and so will it here. So all we're going to be left with is 0. So from all of that, which is really nice because now we managed to narrow it down to this. So it's 2 plus 2 secant of x equals 0. Okay? So, okay, so again, we want to isolate our trig identity. So we're going to subtract 2 to both sides. Then we're left with 2 secant of x equals negative 2. And then we're going to divide both sides by 2. So now let me move it to this side. So now we're left with secant of x equals negative 1. Okay, and we've isolated that. And then, of course, per usual, I'm going to show you how to use your unit circle to solve for this. Okay, as always, we managed to get our trig identity down to our equation down to secant of x equals negative 1. And just kind of as a reminder, because I like to use the unit circle, secant of x is the reciprocal of 1 over cosine of x. And then we know that our solution was negative 1, okay? So we're basically going to look at our x value, okay? So here we go. So when does x equal -1? Well, that only happens at one point, and that only happens at pi. See? And what's the reciprocal of -1? Well, it's still -1. So secant of x equals -1. That only occurs at pi. So at the beginning, they said our interval was going to be at 0 and 2 pi. Well, one full cycle is between 0 to 2 pi, and it only happens one time, and it happens at pi. So they wanted us to find all solutions. Well, our only solution is x equals pi. Okay, and that's it. We don't have to come up with a general solution where we're going to have multiple, because they restricted our domain, and that's at pi, and that's it. Okay, awesome. So let's move on to the next example. Okay, so now we're moving to example 8, and example 8 is basically going to cover functions of multiple angles. So the example that we're working with is cosecant 2 of x minus 2 radical 3 equals 0. So in case you didn't see the difference, how is this different to what we've been doing? Now, in all the equations that we've been doing yesterday and today so far, our angle has just been a single x, but now we're going to do a multiple. So here's 2x, okay? So pretty much what we're going to do is we're still going to isolate our trig function. So treat it as you've been doing and just isolate, okay? So first thing we have to do is we're going to be adding 2 radical 3 to both sides. Again, just treat them like you normally would, okay, as you've been solving. So now we have cosecant 2 of x equals 2 radical 3, okay? And basically what you could say is in the past we've done x equal, oops, let me move this up, sorry. In the past I've done x equals and then whatever we have here, but this time it's 2 radical 3. Okay, so a couple things you should know. We did isolate our trig function, so technically we're done. Okay, all we had to do is add. So cosecant, this is just a side note, okay? Cosecant of x is the reciprocal of sine of x, okay? So just remember that. Reciprocal of cosecant is sine of x, or 1 over sine of x. So in this case, we pretty much have to look for, let me show you. I don't know if this makes sense. If cosecant is 2 radical 3, we're going to solve for sine of x. So 2 over radical 3 equals 1 over sine of x, okay? To get sine of x by itself, all I'm going to do is the reciprocal. So sine of x is going to be radical 3 over 2, okay? Now, the reason why I did this, because you know what sine of x is using your unit circle. It's basically your y value in the coordinates, okay? And we do have a square root of 3 over 2. So now let's use our unit circle, okay? So if you notice, I didn't give you an interval. So this is going to be one of those where we're going to have multiple responses, okay? So remember, sine of x refers to the y value. So look at the y values where y is square root of 3 over 2. So if I look, that happens at pi over 3. And that happens at 2 pi over 3. And I could actually... so pi over 3 and 2 pi over 3. I don't really want to look down here. Well, technically I could. Where do I have another one? Okay, so just we just have those two. You don't want to look down here because down here square root of 3 over 2 is negative, and square root of 3 over 2 are negative. So these are negative. So basically, I just want to concentrate on pi over 3 and 2 pi over 3, okay? So here we go. So here we've isolated our solutions. Now to write our solutions, let me show you what that would look like. Okay, so we would have two solutions. We said according to the unit circle, our angle, again, ignore the fact that it's 2x. Just think of it as an angle for now. Our angle will produce 2 radical 3. Oops, wrong part. I shouldn't have put that here. Our angle will produce 2 over radical 3 at pi over 3 and at 2 pi over 3. Okay, but remember this is a multiple angle because now we multiplied by 2. So to solve for x, ready? To solve for x, we would write pi over 3 and cosecant, since it's a reciprocal of sine, of course, altering functions are infinite, and cosecant also has a period of 2 pi because sine has a period of 2 pi. Okay, so every time it does a cycle, it's going to go through 2 pi, and they have multiple periods because again, these are infinite. So pi over 3 will give us an answer of 2 radical 3, but it'll happen every time there's a cycle. So plus every multiple of 2 pi, okay? And then same thing here. X equals pi over 3, 2 pi over 3, plus every multiple of 2 pi. So we're going to keep getting a solution every cycle, okay? But I want to remind you that technically we should have a 2 there, but we're trying to solve for x. So to get rid of the 2, what we would do is we would divide by 2 to both sides, okay? But just so you know, dividing by 2 is the same as multiplying by half. And the reason why I'm going to multiply by a half is because since I have a fraction there, I like multiplying by a half better, okay? And when you multiply to a half, you have to do it to everything, because whatever you do to one side, you want to do it to the other side, okay? So again, dividing by 2 so that we can get x by itself, okay? Or multiplying by a half. So I'm going to start with the first one, okay? So basically what's going to happen, I'm going to distribute my half here and distribute my half here, okay? So my first solution, and these are general solutions, okay? It can't be a specific one because they didn't restrict our domain. So basically, we're going to get these solutions through every period, okay? So our first solution would be pi over 6, because you want to distribute, plus the 2's will cancel here, and we just end up with n pi, okay? And the 2 and the 3 ended up multiplying there, okay? That's our first solution. Now in our second, we're going to have, I think I could do it here. Okay, in the second one, we're going to have x equals, and then when we distribute, the 2's will cancel, so we'll just have pi over 3, plus, and then when we distribute here, the 2's will cancel, so n over pi. And these are our two general solutions. And just like I stated yesterday, because they didn't restrict our domain, remember, we're going to have multiple solutions, okay? All right, boys and girls, so now I'm going to have you guys try the checkpoints for example 7 and 8, and then I'll have you check your solutions. And again, if you need clarity or help with anything, just jump back in the chat and ask, okay? Good luck.